my guide, I'll shine bright like fucking Elon Musk.
Hi guys, welcome back to my YouTube channel. And today I thought of doing something interesting, and that is to research everything about oil. And so the video itself is going to be everything about oil, and we'll talk about not just talk about it. I'll do research live, and later I'll upload this video on YouTube, and I'll be doing the entire thing about his oil history, its origin. Yeah, of course, it's going to be crude oil, and then there are a lot of misconception. There are a lot of myths about it, and yeah, so how it led to the industrial revolutionizations, and what are the importance of the oil, and eventually, it's going to be what is the present conditions of the oil, and what are the geopolitical consequences, and what are the implications of the oil, because right now the Iran war is going on, and because of Iran war, there's a lot of inflation. The increase in the price of the oil, which leads to increase in the price of basically everything because of the transportation and all. So how the choke points of different countries handle each other, and how the global oil supply works, and even the basics about what are the how many liters and how many consumptions of oil is there, and which countries are the largest producers of the oil. From 0 to 100%, I'm gonna cover everything, and on top of that, we'll also talk about the what are the futures of the what is the future for the oil, because right now, because of the sustainability being enforced from most of the governments, especially the West, because of the developed economy and all. So we're going to talk about what's going to be the future for an oil, because it's obvious that oils generally uh, you know emits a lot of pollutions, and now most of the countries are focusing on no, sustainable developments, other renewable energy, and how it's going to be. So let's talk about from this to then entire everything history and all. And I'm not exactly sure how long this video is going to be, because I do have a 70 pages entire document. I've prepared it. I've not. I mean, I've read it everything. I've prepared this everything, and I've not done like a deep dive research about it, and I'm particularly could be aware of some topics. Even I'm not aware of other topics, so there I'll just go deep down inside and what is happening and all. And yeah, so this whoever is watching, it's basically like doing a reaction video. Most of the YouTubers do, right? They just react the entire thing, and then it's going to be the same. And initially, I thought of doing like a 6 part YouTube videos of 20 minutes each, but then I thought like most of the time will be mine will be will go towards to editing, which I think it's a very important thing, but I think it does not add any value to me. So I don't want to waste my time on editing, because editing is a lot of time. It takes a lot of time. So because of that, I'm doing the entire recording. There's no cut in between. There's only two cut: initial one and the last one, two cut, and there's not going to be a cut at all in this entire video. And yeah, so I think it's gonna take some time, and we'll talk about everything: geopolitics, how the country manages oil supply, oil demand, oil productions, how organization like OPEC controls the price of the oil, and why because of the petrodollar, which was a sign, an agreement between Saudi Arabia and the United States, led to the dominance of US currency dollar. And we're gonna talk about everything, and then will there be a decline in the power of US dollar, because right now the petrodollar contract is has expired. So yeah, it's gonna be an interesting one, and I'm gonna do everything. So yeah, so first YouTube videos on everything about oil. Okay, this is it. And part one, we'll talk about the birth of oil, how crude oil formed. So introductions to before oil powered the world. Today, oil power cars, airplanes, ship factories, and even produces plastic and chemical. Modern civilization runs heavily on petrols. Yet, crude oil was not only buried beneath the earth waiting for humans. To understand oil, we must travel back hundreds of millions of years to ancient ocean long before human existed. So we're talking back about like 100 to 500 years ago. Earth during ancient times. Earth looked very different. Large plants of the planets were covered by shallow oceans and seas. These waters were filled with microscopic organisms, algae, platforms, tiny marine organisms, microorganisms. Unlike the common belief that the oil came from dinosaurs contributed very little. Most oil originated from tiny marine organisms, not giant animals. This is why the phrase "oil is dinosaurs' juice is scientifically inaccurate. Yes, this is very much prevail. This is the very much the conversations that oil we have a oil. It's because of the dinosaur, and it is considered as a dinosaur juice. No, it is not. So this is exactly clear. It's scientifically inaccurate. Dinosaurs lived much later and existed mostly on land, while the primary ingredients of crude oil formed in a marine environment. Okay, and the beginning of the oil formations, when these microscopic organisms died, they sank to the bottom of an oceans. Layer of mud and sediments buried them. Oxygen level at the sea floor were very low often. Low oxygen was extremely important because less decomposition occurred. Organic material remained preserved over millions of years. Layers upon layer of sediments accumulated. So the deeper burial create enormous heat, mass pressure. So what happens with is that if you see the soil, there's a different layers of soil, right? So there's a top soil, then there is the soil layer of soil, and then at the coast there is all a lot of rocks are there. And what happens with the deep inside the soil is that because of the earth inside there's a crust, right? So the crust because of the heat there's a lot of heat inside the earth, right? And what usually happened is that back then, right now, most of the I'm not talking about animals. We're talking about the human. If the human dies, we just go to the some again. Most of the people what they do is that they don't organically bury under the soil, but instead what they do is that they are buried in the cement thing, which is not a healthy way of doing it because what happened is that we came from the soil and we have to go under the soil itself. But most of the animals back then, when animal dies, they just will they'll just be left over the the ground, the upper grounds, and then gradually what happened is that and a different layer of the soil will come soil, and then later what happened that dead animal, right? It gradually goes inside the earth, and then that leads to the formations of coal and the crude oil as well, right? Because of the decomposition, because of the heat inside the earth, so less decomposition occur. And okay, so yeah, less decomposition occurs, and this one's okay. So yeah, I was talking about this thing, right? Okay, I'll just show you about. We'll do simultaneous live research about it. So this is my email ID, and please, no. How dead animal, right? So how dead? Okay, just wait. How ancient dead animal led to crude oil? I mean, we could see some visuals. I'm hoping. Okay, yeah, I think I could see some visuals, right? So this is it, right? It's okay. I'm not exactly okay. Just one. Let me show you the clean picture. Okay, so this is what happens, right? So there are millions of years, there are a lot of oceans, and it's mostly because of the ocean, right? A lot of animals inside the oceans, and then when the water dried thousands of years ago, and then it becomes entire place and then the entire dead animals, right? It just goes inside the deep soil, and then that deep soil because of the inside us, the heat, it led to the formations of the crude oil and coals and all those things. So yeah, I mean images are not clean. Yeah, so this is exactly clean. Okay, so the oceans, all the small. So I was talking about this thing, right? Small marine organisms, oceans, and gradually the ocean started disappearing. Then the ocean, then there's a sediment rock, and then later when the ocean disappeared, I'll give you a nice interesting fact about it also, right? Okay, so now because of this, now you could see all the dead animals, right? They've just started going down and buried. Now this is where they are. So this is the right now this is the earth, and this is the surface. This is where all of the humans are right now present, and not just human, all the most of the animals also. And then this is the topsoil, right? This is the topsoil, and then there is sediment and rock, and then this is where the trapped gas, which where this is actually the the dead animals of the millions and millions millions of years ago. So this is the trapped oil, and then this one's okay. So I'll also talk about the soil layers of earth. So this is how it is, and soil layers of earth, including uh, crude oil. Let's just type something like this. So yeah, this is how it is, right? And this, okay, so you might have seen some oil rig, especially in the oceans, where, so this is how it is, right? This is the platform, this is also the driveway, and then this is the soil, and then there's a gas, and then there is a oil, and then there's a water inside it. So the water also, right now we have the well and all, right? So, okay, wells in some plus hand pump and all. So all this water also comes from this the inside the soil itself. So this is oil. This one, this okay. This is a rake. We'll try explaining later or study about how the oil rig, right? How they pump oil, drain oil from the inside to the outside. And okay, this is the layer, soil layer. So first is equals to humus, and then this. Okay, so first the initial upper layer it's called humus, and then we have a topsoil, and then we have a subsoil, and then we have a parent rock, and then we have a bedrock. Okay, that is about it. And then I also want to show you about an interesting fact is that most of the people might not know that. I'm not exactly sure if they have under this one thought about it or not. Why is it that the Middle East, current Middle East, they have so much of an oil? And when I search it, I was actually very mind boggled with the fact that earlier, millions of years ago, the entire place, right, of the Middle East, it was a giant ocean. And it was a giant ocean. And then later, because of it was a giant ocean, there were lots of organisms living inside the living inside the ocean. And then later, when the ocean dried up, so all the animals were killed, died, and then that all the animals are buried inside those huge desert. And then because of those animals are dead, they have because of that, because of the heat also under soil, which are very very deep, that led to the formations of the huge natural resources oil for the so okay, so why Middle East has so much of an oil? Okay. The Middle East has nearly half of the world's proven oil reserve because of its unique geographical mystery. Okay, millions of years ago, the region was covered by the warm, shallow Tethyan, okay, TEH, Tethyan Ocean, massive accumulation of marine organic matters, idle underground seating, and large dome structures to combine to create the trapped petroleums. Ancient tropical oceans for hundreds of millions of years. What is now the Middle East was an expansive shallow sea. Plankton, algae, and marine organisms thrive in tide. Okay, just what is the plankton? Okay, I want to show plankton. Plankton. Okay, so these are the animals like which looks like this. Planktons. Okay. Okay, so because of this, on a perfect cooking condition, the tectonic plate shift the ancient. Okay. Okay, I'll also show you the map of it, right? Okay. Uh ancient what is that name? Tetlan. T E T E H T E T H Y N Tetlan C. So most of the people might not know that India, right? India country was not there back then. And later, because of the tectonic shift and all those, India joined the other one. So which one is the accurate? Yeah, I think this is the accurate. This is the accurate. Okay, just wait. Ancient India map. Ancient India map where it was part of Africa. So most of the people might not know that. Okay, 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 okay. So where is interesting fact? Hmm, it's not there. Where it was a part of an Africa. Where is the map? Where where geography of India was part of India. That is much, much earlier. So yeah, this is exactly the picture of it, right? Not exactly sure, it's not able to see. So see, this has also led to the formation, the nice interesting fact is this has also led to the formation of a Himalayas, right? This was a part of India. So just wait, this is it, but this is not the full picture of it. Let me show you where is the okay, formation of Himalaya, right? Okay, formation of Himalaya, Himalayas, in technology theory. Yeah, so this is it. This is the picture of it. So initially, if you see the map, India, millions and millions of years ago, India was not in the Asian, country. It was not in Asian country, but it was under, it was actually a part of an Africa. And then gradually, what happened is that India started moving away from the Africa, and then uh, it it actually attached with the Asia, the current Asia, and then in between there was a big ocean back then, right? And it started, when it just went. See, okay, Indian plate today it goes to Indian land masses 50 years ago, and Indian land masses 70 years ago. So 70 million years ago, right? Okay, so then it shifted, it touched, attached with itself with the upper, the East Asia, and then when what happens when the two tectonic plates merge is that there will be something of a mountain sort, and then because of that entire thing, that is how the entire Himalaya formed. So see, this is exactly the how it works, right? When two, this is the one part and this is the other part. When two plates merge, and in between, what happened is that there will be a formation of some mountain, and that mountain currently is known as the Himalaya. If you could see, I wanted to show a formation, right? Okay, a formation of Himalayas. Okay, I want to show something different. Okay, is it this? Okay, is it this? Yeah, so this is exactly a part of it, right? See, okay, India was not a part of it, but India was there. India is there, right? And then it gradually moved there and it just attached itself in Asia. And then when two tectonic plates merge, and in between, what happened is that something comes up, and that is the mountain, and that is the Tibetan plateau and the Indian plateau, and then just there's a Himalaya in between. So that is how it is, and then that's what I'm saying, right? So there was a huge ocean when they were two separate. There was a huge ocean in between, and then that ocean later dried up. In the entire regions, and then that led to the formation of a Middle East on the left side, and then because of that, a lot of organisms and all are present there. So right now, it's all because of that thing that there's a lot of oil inside Middle East. So I was okay. Okay, so I was here, right? I was doing that thing. Why Middle East has so much of an oil? Mm, The Middle East has a vast amount of oil because it was a warm, shallow, tropical, this one took a unique, stable geopolitical history that perfectly ancient, Tethys. Hundreds of millions of years ago, the region was known as the Middle East, sat near the it formed the shallow water of ancient Tethys Ocean, abundant life, thick sediments, deep burial, cooking, the oil windows, the heat, and this one's okay. But then, how is it, and then suddenly, and then now, why, okay, why does he, what is it all covered by desert? It's mostly desert, the entire Middle East. Yeah, ocean dried up, but that does not have to be. The Middle East is not entirely covered by desert because it is, diverse topography completely disrupt global wind patterns to creating vast mountain ranges, fertile river valleys, and lush coastal ridge. While a major planetary dry desert blanket the southern part of this one, the subtropical high pressure belt. Okay, the vast desert like the Arabian desert exists because the southern Middle East sits between 20 to 30 degree of the equator. So it has to do mostly with the geography, the Earth in a position sinking by air because this latitude is dominated by the global air patterns where warm air rises from the equator and sinks back and down with the tropical snow classes. The air shrinks, it compresses and dries out. Okay. As the air sinks, it compresses and dries out, completely suppressing cloud formations and rainfall. This creates a massive desert expanse stretching across Saudi Arabia, Oman, and UAE. Mountain walls catch the winds. The geography, changes entirely as you move, north and east into the countries like Turkey and Iraq. The topography affects massive mountain region like the okay, not all Middle East, but yeah, I was mostly talking about the okay Himalaya. Okay, Himalaya in world map. So you could also see this, right? Okay, and most of the people might not know that even entire Tibet region, right? This entire region, the right now which is undercover. This is the Himalaya. Okay, this is the Himalaya, and this is the entire India. This is the entire Tibet, which is right now under the China. So what happened is that in China, even Tibet is a very deserted place. Deserted in a sense, it's very dry place. Do you know why? Because when the ocean, when the the monsoon season in India, right, it comes, the monsoon wind. So most of the time, what happens is that the wind brings the rain. So when the wind goes from here, then what happens is that it's not able to go to the other side, the Tibet. Why? Because there's a huge Himalayas, right? And then the cloud, right? It gets trapped there, and then it actually starts showering there itself. So okay, I'll tell you what happens, right? When the wind goes there, and when it's not able to go to the other side because of the huge mountain, when a lot of cloud forms, then it becomes very heavy and it just drops there itself. So that's why this area of India is very, has a very fertile land because of because obviously because of the river, and also because of the fact that it rains a lot in this area. Okay, so this is the Himalaya mountain. So this is the mostly mountain part. This is the Himalaya mountain, and this is the Altai, and this is the Ural. Ural mostly I think it is basically a natural border between Russia and the Europe, Urals, and then there's a Scandinavian one. There's an Alp mostly known for Switzerland and all, and then there's an Atlas. Okay, then there's Rockies and there's okay. So let's go back to our this. So heat and pressure, nature's underground factory. As boreal depth increases, temperature slowly rises. Scientists often describes oil generation as earth natural pressure cookers. Organic matter underwent a chemical transformation. So first there's an organic matter, okay, and then okay, so that's how the crude oil, the natural gas, everything is under this one. And okay, we'll also understand how there's a differences of crude oil and the differences of a natural gas. It has everything to do with the heat, the level of heat. This process took okay millions to hundreds of years. Temperature matters greatly. Too little heat, no oil forms. So what happened is that okay, so when something dies, the living organisms die, it gradually goes because because of the new soil, new everything comes. It gradually goes inside the earth, and when it gradually goes inside the earth, it depends on how old is it. If it's very old, then obviously it will be near the crust, right? The earth's very deep, and if it's a new, then it's actually much uh, outer, or it's still inside, it's much outer than the previous one. So that's why if it's very inside, then it becomes too heat. And when it if it becomes too heat, then there's no oil, because I think it gets turned into liquid or something. And then if it's very far, that means if it's the newly in diet animals, newly in a sense, 100,000 something, because here we are talking about the far means millions of years ago, right? And recent means we are talking about thousands of years ago. And if it's 1,000 years ago, it's not very deep, but yeah, it is deep. It's not very deep. So that means it's not very hot. So that's why even there, the conditions of the oil farming is very less. So see, too much heat, oil cracks further into natural gas. Okay, so the problem is this one, right? When the earth, when the animal dies, if it goes very deep, that means if it's very old, then it because of the extra heat, it just converts itself into a natural gas. So too much heat, oil cracks further into a natural gas. Scientists call the ideal oil generating zones, the oil window. Approximate temperature. Approximate temperature equals to 60 degrees Celsius to 120 degrees Celsius, okay, and below equals to not enough transformation, above equals to gas dominates, okay, and if it's okay above 120 degrees Celsius, then it'll become a gas dominant. This concept becomes important later when discussing explorations, okay, and then okay, fourth is equals to source rock. Source rock, the birthplace of an oil. Oil does not form randomly underground; it forms inside a special rock called source rock. Okay, usually shale and organic rich mudstone. Okay, source rocks act as the birthplace where organic material transforms into hydrocarbons. However, oil usually does not remain there because oil is lighter than surrounding water. It begins moving upward through tiny pores and fractures. This movement is called migrations. Okay, source rocks act as the birthplace where organic material transforms into hydrocarbon. Okay, usually what does not come random this one, it forms inside a special rock called a source rock, usually shale, organic rich mudstones. Rich sources rock is the place where the organic material transforms into hydrocarbons. However, oil usually does not remain there. Oil goes, because oil is lighter than surrounding. Okay, this is known as migrations. I think we'll get to it. Okay, so we'll see here. Uh, Oil formation inside okay rock. So I'll show you, right? It's called shale. Oil does not exist in large dark underground pools. Okay, so yeah, most of the people might think that okay, right now, okay, some people are drawing out oil. Okay, that means underground, deep underground. There's all like oil. No, it's not like that. Uh, because see, okay, formation of a rock. I'll show you. Okay, I think some oils. I think considerable in amount of a time of the oil are extracted through the rock. Oil formation inside rock under soil. I don't know if it's there or not. Okay. Mm-mm-mm. Shit. So yeah, so this is how it is, right? So this, see, it's not entirely like liquid, but this is how it is, and then from there, I think it is extracted, like this kind of a rock. Rock of the week is equals to shale. Okay, I'm not able to see it clearly. So let's see what is shale. Shale is most abundant sedimentary rock on Earth, making up to this one planet's sedimentary crust. Okay, yeah. So making up roughly 70% of the planet's sedimentary crust. Crust, okay, crust. It is formed by composition of compaction of a mud, clay minerals and tiny particles over millions of years. Fine grain, it mineral grains, fossil visibility. Okay, just wait. Shale.
Shale is the most
Okay, shale. It's pronounced as shale. Generate electricity, it harm. Okay, so yeah. Now let's go to the next topic. It's called migration. Now we'll talk about the reservoir. In reservoir, rock is equals to nature's storage tank. After migration, oil can accumulate in another type of rock. Reservoir rock characteristic equals to porous, permeable, able to store fluids. Example: sandstones to limestones. To the tiny space between grains act like a storage containers. Imagine a sponge filled with the water. Okay. It's like a sponge filled with the water, and reservoir rock functions similarly. Without reservoir rock, oil would continue moving and disperse. Okay. That's reservoir rocks to nature's storage tank. I'll just to get a better understanding, let's just see a picture of it. Natural selections. Hmm. Yeah, I think it's something like this must be there. So yeah, this is how the drilling also works, right? Okay, there's a drilling. So this is the this thing stand. Okay, so oil, gas. This is the gas, oil, water reserve. Okay, this is the reservoir stock. PM. Okay, permanent rock stock. Okay, I just want to see. Okay, how deep does most oil come? I mean, framing the question might be wrong. How much extract 1 kg mustard? Okay. Crude is typically found between 1,000 to 20,000 feet beneath Earth's surface. With the oil window, the heat and pressures are ideal for liquids, peaking between 7,000 to 15,000 feet. However, the deposit can be covered much deeper. Okay. Come in kilometers. Let's talk about in kilometers, right? I don't think it'll be in kilometers also. Most oil is typically found at depth between 2 to 5 kilometers, about 6,000 to 1,600 feet below its Earth surface. It's highly specialized depth zone is often referred as the oil window. Okay, so that's why, okay, initially we had this one oil window, right? So oil window is basically between 2 to 5 kilometers. And it's actually, if you just imagine, right, 2 to 5 kilometers deep inside the earth, it's a lot, man. So see, even the ocean stops here, right? The depth, the depth of oil wells, right? Okay, Burj Khalifa, it's here. So you could see Grand Canyon equals to average Texas equals to oil and hydraulic and fracturing between 5,000 to the suns. And then here you could see all the dinosaurs. Okay, okay, this is the, I think this is the ocean, right? This is the deepest ocean if I'm not wrong. I don't know. Let's see. So temperature this well about 400 degree. Okay, this one stand that's pretty okay. So you could see right how deep it goes. So Colombian Comodo said to be the world's deepest well. Okay, Colombia's Comodo said to be world's deepest well. So this is the Colombia, a deep oil wells, but this one is too. So Colombia is equals to it's 12,900 feet. That's a lot. Okay. This is Angola, Namibia, and Brazil. It's actually a very deep, man. And reservoirs, okay, and tiny specks, okay, this is done. And cap rocks. So the missing piece often forgotten. Very important concept often missed. Cap rock. Cap rocks are impermeable layers. Examples, salt, shale. Okay, their purposes. They trap oil beneath them. Without cap rock, oil would continue rising and eventually leak to the surface. Oil accumulation requires source rock, migrations, reservoir. Okay, so oil accumulations. So if you want to do something, if you want to extract an oil, this is exactly what it needs. Otherwise, if it's not there, then the oil, right, just goes everywhere. Yeah, it leads to the surfaces. So first, there's the source rock unit, and then there should be a migrations, and then there should be a reservoir rock plus cap rock. Missing one component can mean no commercially viable oil field. This becomes crucial in petroleum explorations. Okay, so this is important. Not this is important, I think, because just imagine. Okay, when you find an oil, a place where there'll be a lot of oil, when you and you have to spend a lot of money. I think in between $100 million something to make that extraction thing happen. So for the extraction, you have to put a lot of machineries around. And if the oil is not in one place, if it's fragmented into different places, then you have to build multiple machines, right? So that's why this one is important, because if all the oils are in one place together, and it's only possible when there's a source rock, plus there's a migration, plus there's a reservoir rock, plus there's a cap rock, which we have all seen. And if it's not there, then it'll be in a fragmented leaked. It becomes very difficult. It's not commercially viable, because if you're they're spending $100 million, then obviously you need some oil which is more than $100 million, right? It's possible because of the all those things. Okay, missing one becomes commercially not viable. This becomes crucial for petroleum explorations. So that's why right now, because see, okay, the government has to spend a lot of money. So mostly it's a private right now. They have to spend a lot of money. First, they have to dig and do the research and developments, and then they have to put up the entire machine. What if they don't find even a single oil? What if they find a very low oil, very less oil? Then they have that's actually a waste of money. Then they have to search for a different one, because you cannot get oil in one place. You have to search for a different place. You don't know where the oil exists. So that's why it's becoming very difficult. Okay, seven is equals to oil traps. Why some places have a giant oil fields? Yeah, so now this is it. Oil accumulates inside a geological structure called oil traps. Major types equals to structural traps created by movement of Earth's crust. Example, anticlines, fault traps. So stratigraphic traps created by rock layers, which changes oil trap for millions of years, eventually form giant fields. Example includes a huge reserve in the Middle East. So this is exactly why Middle East has so much of oil traps, because of the giant fields. Okay, and number eight is ancient human used oil long before modern drilling. So most of the people think that okay, oil just came recently. Yeah, I mean oil did not come recently. Okay, it was there, but we've started using because there was an invention of what oil could be used. Right before that, yeah, there was a oil, there was a use, but we don't know that it could lead to this one. So now talking about this one, humans discovered surface oil thousands of years before industrial civilization. Natural oil sometimes leak to Earth's surface as bitumen. Bitumen, I think the pronunciation is bitumen or something. Bitumen. Bitumen. It's basically like used for the road building and all.
Bitumen.
Bitumen, right? Okay, it's bitumen. So yeah, so these are the bitumen, and this is basically used for the road construction. I think it's also known as an asphalt. And okay, no, this is the asphalt. Okay, this is the asphalt, and this is the bitumen. Which one is better? Which is better for road construction? Road construction, okay. Construction, asphalt versus BITU, bitumen versus concrete. Concrete, I think, is it expensive? So this is asphalt is equals to comparisons. Okay, concrete and equals to comparison of driving comfort. Yes, this is better. Comparisons of driving operation cost is equals to. Oh, I think concrete is much cheaper if I'm not. Okay, it seems that it's much cheaper. Asphalt versus concrete. Okay, no. Asphalt versus bitumen. Let's see bitumen. It looks like a bitumen is better. Okay. Asphalt is generally better for durable roads and heavy traffic, while bitumen is cheaper and ideal for light traffic driveways. As a okay, no, this one they aren't mutually exclusive. Asphalt is a mixture that uses bitumen as a sticky binder. Okay, so asphalt is much more, is considered, let's asphalt is mixture. It's not okay completely exclusive. Okay, it is a mixture that uses bitumen as a sticky binder. Okay, understood. So asphalt is much better, and but I think it's expensive also. So ancient times, natural oil sometimes leak to Earth's surface, and as a bitumen, so it is leak. So they've not this one they're not digging some earth, but it just comes out naturally, leaked bitumens. And bitumen is a thick, sticky petroleum. Ancient civilization used it for Mesopotamia. So most of the people, just a fun fact, Mesopotamia is the ancient civilization, the oldest civilizations. Right now, it's current Iran, in around Middle East, Iran places, waterproofing boats. So if the boat has some hole in it, and obviously they can't go because the water will come inside. So that's why they use it as as a more waterproof, just to apply it in the those hole surfaces, and then ta-da, it becomes solved, right? So hole is filled. Ancient Egypt embelling practices. What is embelling? Embelling practices. Search what is embelling practices. Embelling practices. Embelling practices. Modern ambling temporarily delays decomposition, sanity remains, and restores like flexibility appearance. What is ambling practices? Meaning, ambling refers to the art and science of artificially preserving human remains to slow down decompositions. It typically involves draining bodily fluids and replacing them with the chemical solutions. Okay, ancient ambling practices means ancient ambling practices represent the earliest systematic used to preserve human remains from decompositions, while human culture and roses. Okay, so it uses for decomposition. Okay, okay, so to ensure that the body remains fresh, okay, something does not decompose. Okay, road and construction, okay, binding material, adhesives, right? Okay, sealing buildings and tools. People knew oil existed long before engines were invented. Simply, they didn't know its enormous future value.
I will talk about the oil basics everyone needs first. And yeah, so the basic thing in oil world is that before studying any global market, measurements must be understood. So yeah, so we'll talk about the measurements of the oil, and first is equals to why is oil measured in barrels. So if most of the people don't know, but yeah, I'll just show you the barrel, right? How does barrel look like? So this is a barrel. So oils are usually measured in either a barrel or a gallon, right? So oil is measured in barrels mostly, and one barrel is equals to, so to give you a context, that one barrel is equals to 42 US gallons, or one barrel is equals to approximately 159 liters. So that means one barrel is equals to 42 US gallon or 159 liters. Now, just to give you a little context for international readers, it's going to be 159 liters is roughly two large bathtubs of a liquid, right? So, yeah, and historical reasons. During the early, American oil industry in in 1800s, producers transported oil using wooden barrels. So that's why it has become a standard now. And it's not just that it's 42 liters barrels are there, but it's mostly there are like 40 gallons exist, 45 gallons also, others also, but they standardized, right? Eventually 42-gallon barrel became industry standards. Even though now oil travels through a pipelines and tankers rather than a barrels, the measurement remains. Okay, the barrel became a permanent unit, and abbreviation for barrel equals to BBL. And useful visual suggestion for your paper. So 159 liter rum besides an average humans. Okay, just wait, I'll just show a little context to how much what is the worth of it. And yeah, so yeah, this is how, okay, this is the I mean, there's no exact okay, so it's not there, but yeah. So caption, one barrels of oil contains approximately 159 liters. This helps readers immediately understand the scales, right? Okay, and understanding the production numbers. So oil production is often described as barrels per day. So BBL, this measured daily output. So example equals to a field producing 100,000 barrels per day, and means is equals to, so 100,000, okay, yeah, barrels is equals to 159 liters. So every day, day they produce 15.9 million million liters every day, and million barrels per day is equals to, so million barrels per day. Countries often produces millions of barrels daily. Example, Saudi Arabia produces several million barrels per day and is among the world's largest oil producers. This number changes over time depending on the market demands, production policies, and global events. So yeah, you just have to understand this very carefully, that um, it also depends on the market. It also depends on the market demand, right? If the demand is more, then obviously you have to produce more, so that the supply remains constant. And if the demand is less, so see, okay, demand could be less because of the several reasons. Demand could be less because of the war going on happening, and the supply, the supply line is separate. There's also could be a scenario where uh, the supplier or the producers, they intentionally keep in artificially keep the productions shorter, because then there will be less supply, and demand more or less will be same. So that's why the prices will increase, and then when the prices increases, so they produces and then to try to sell them. So what happens is they artificially creating a scarcity, and the prices will increases. This is actually unethical practices, and I think it's illegal also to some instances. But yeah, if it's international and if it's illegal, but even if it's doing internationally, then no country can do much about, like, only the UN can step in. So yeah, some do that. So okay, global events, this changes over time. Okay, so we'll talk about the now what are oil reserves. Okay, first we'll talk about the uh, just wait, okay, yeah, now we'll talk about the uh, now we'll talk about the which country produces the most oil currently 2026. So the United States produces most oil in the world, comfortably holding the top spots. Okay, so top three global oil producers led by margin and wide margin investors. So right now, currently, the United States produces 13.5 to 20 million barrels per day, depending on the petroleum metrics measured. Saudi Arabia produces 9.5 to 11 million barrels per day, and Russia is supposed to produces 9.8 to 10 point 8 million barrels per day. So yeah, this 2026 there is the absolute. Okay, so first it goes to Venezuela. Okay, so top 10 producing countries with the largest oil reserve. So this is the largest oil reserve. Okay, so this is the largest country. So the production and the oil reserves are very different things. So production means how many barrels of oil they are producing, and the reserves means how much they can produce, right? And yeah, so you can produce a lot, but if you're producing it less, it could also be possible. And yeah, so production means the currently how many they're producing, how much they're producing, and the reserve means how much they can produce based on an estimated, right? So now we'll talk about the next topic, and those topics are what are oil reserves, right? And so yeah, oil reserves are production and reserves. Yeah, see, the production and reserves are different. Production is equals to how much oil is extracted daily, how much it produces, and reserves is equals to oil estimated to remain underground and economically recoverable, right? Country may have a huge reserves but produces very little. Just to give you a little context, it's like this one. Okay, so for example, yeah, so so based on an estimates, because we don't know for sure, based on estimates, we know that, okay, just to give it an example, if India has a reserve, that means by doing a survey, we know that we have a 1 million barrels of oil in that particular field. That means we can extract this much of a field, but right now we are only producing 100 100,000 million 100,000 barrels per day. That means our production is 100 million barrels, but our reserves are 900. That means because that one is already produced, now we have 900 more, right? 900,000 barrels more. So that's why that one is the reserve, 900,000 more we have, but the production is only $100,000. So yeah, that is the simple definitions, examples. So yeah, look at it. Okay, how much oil is extracted daily? Reserves equals to oil estimated to remain underground and economically recoverable. Countries may have a huge reserve but produces relatively little. So others may have produce large quantities while have a smaller reserves, remaining reserve. Reserves are often expressed as a billion. Okay, is expressed on billions of barrels. For example, a country with the 250 billion barrels of reserves means enormous future product. Yeah, so enormous future production potentials. And okay, so if I look at it, then okay, so country which have a largest reserves are Venezuela. So Venezuela have 303 billion barrels of oil. That means if they were to produce oil, all the oil, they can produce 303 billion barrels. That's a large reserves, right? And but they're not producing this much because the demand is not that much. So they produce based on the demand. And yeah, are they OPEC members? Yes, they are OPEC members. And second, it goes to Saudi Arabia. Saudi Arabia also have a very large reserve, so 267 billion barrel of reserve, and Iran 209, Canada 163 billion, Iraq is equals to 145 billion, UAE 113 billion, Kuwait 102, Russia 80, United States 84. So this is the classic example, right? United States has the highest production, and but if you see the reserves, they have, I wouldn't say they are in the ninth spot. It is 74 billion reserves. Libya, Venezuela officially holds the largest oil reserve in the world. However, the country faces a major challenges because of the nature of its oil. The resources here is extra heavy, meaning it is okay. So even there's a quality, okay, different inequalities of the crude oil that you are extracting. So see, meaning it is thick and very difficult to process or refine. Furthermore, political instability in the US sanction have limited the nation's ability to export oil efficiently, even though the country has a massive potential. Poor infrastructure currently stops. It's also possible that you don't have enough. So okay, I'll tell you an example why most of the people are not buying Venezuelan oil is that first is their oil is a little different. It's written properly, right? They have a extra heavy and thick and very difficult to process or refine. So you have to understand that when the crude oils, right, are extracted, they're not directly used for petroleum or any of those things. It has to be refined, and for the refinery, it has to be refined in a factory, right? So, and there are different types of oil. So that's why you need different types of refinery, this one. So this one is a little difficult to, this one refine. And even in refining, okay, you have to pay a lot of money for that. If the oil is, oil is different and difficult one, then yeah, you have to pay more. And second, because of the US sanctions, right now, because of the recent news, I think the Maduro, right, the president of the, so you have to understand that the Venezuela is a, it's not a democratic country. It's a, I think, not necessarily a dictator, but it's an autocracy. And yeah, so the leader, right, the Maduro, he was captured by the United States. Now, we have to see what they are going to do it, because they have a massive potential, but because they don't have the they don't have the proper infrastructure and all the technological advancement to extract this and refine it and then sell it. So that's why the first one. And then second equals to Saudi Arabia, top 10 producing. And then Iran processes their abstract oil reserves, especially near the Persian Gulf region. Unfortunately, international sanctions are limited access to modern technology. Canada also. Okay, so this is this one, right? So now we'll talk about the oil production. Okay, oil production, largest in the world, and let's see how many. So okay, production United States goes to 13 million barrels of crude oil daily, and then Saudi Arabia 10 plus, and Russia's, okay, Iraq, okay, this one, right? Now we'll take an example of India also, right? India's oil reserves. So if you see oil reserves is equals to, so India holds approximately 4.5 to 6 billion barrels of proven crude oil, ranking reserves 23rd. So India globally, this one ranks as 23rd, because the country imports over 88% of this one, right? Okay, so you have to understand that India also, right? Okay, India oil produces how many, how much India does produce equals to, India produces approximately 952, okay, thousand barrels per day, about 28 million metric tons annually of a crude oil, rank as 20th largest oil producer global, despite, okay. So in terms of this one, India does not have that much of a natural resources in terms of oil, but it has others like thorium. We'll talk about it later. So most of the India's oil comes from, okay, some part of an Assam, and yeah, Mumbai High. This is actually a offshore one, offshore, and the, yeah, Ankalesh, Kalala, this one is Gujarat and all those things, right? Okay, this is on field, and yeah, but I think I've read it somewhere that the India, right? Okay, India, their production only meets 10% of its demand, so other 90% it has to import from somewhere. So yeah, so now we'll talk about it also, right? Okay, a major India, major import of India oil from which all country? So India imports crude oil from over 40 countries. That means it's a good thing, because there's a diversifications, and to meet more than 85% of its energy. That means 85. That means 10% might come from the local oil production in India, and 5% renewable source of energy. I think Russia is equals to, and Iraq. So right, Russia is at first. Russia, and then there is Iraq, and then there is a Saudi Arabia, and then United Arab Emirates, and United States also with this one. Okay, Russia emerges the largest single contributor, according to, for over third of total of this one third. Okay, and then all of those things. And but you have to understand what India is good at is that India imports a lot of crude oil. That is no doubt about it. But if you see the largest refinery, we'll talk about it later. The largest refinery that is in India, that is owned by the Reliance Industries. That is a big geopolitical leverage that India has. Is that the largest oil refinery in the world is in India. So what they do is that they import a lot of crude oil, they refine it into petrol, into diesel, into other important resources, and then they sell it back to other countries. So we'll talk about it later when the time comes. And now we'll talk about, okay, so this is the oil reserve, and now important points you'll miss in conventional versus unconventional oil equals to, according to, adding this earlier help later explains to conventional oil equals to easy to access liquid crude trapped underground. So yeah, the conventional equals to, there are different methods, right? Conventional oil means it's easy, just access equals to just make a big machine and then extract as much as this one. Easy to access liquid crude trapped underground. Now unconventional oil equals to required advanced extraction methods. So in some sense, okay, you cannot directly extract it. You have to use other methods, and that is requires advanced extraction method. Example equals to shale oil. Shale oil means, I'll show you example, right? Shale oil means it's, I think, rock. Shale oil. Okay, so shale oil means it is like this. Shale oil. So you have to extract. It's like a rock, and you have to extract from here. So this is the example. Repo. Okay, it's not can't see it properly. Okay, let's go back there. And then shale oil is an unconventional crude oil trapped in fine-grained, low permeability sedimentary rocks such as kerosene-rich oil shale or organic-rich shale. It is primarily extracted using a combination of horizontal drilling and hydraulic fracking to force the trapped hydrocarbons to the surface. Oil versus shale equals to oil shale versus shale oil is equals to shale oil is a solid rock containing kerosene, and to extract oil from it, the rock must be mined and heated to extreme temperatures. Shale oil equals to tight oil equals to, in a modern usage, this typically refers to liquid petroleum. This one extraction. Drillers drill vertically and then curve extractions. Okay, shale oil extractions. So yeah, this is how the extraction process works. Shale oil in a master is equals to, this is the machine, and okay, this is the surface and water and chemical, and this is the shale horizontal. Okay, so you cannot go directly. Okay, this one, okay, vertically, you have to do it horizontally, and hydraulic, fracking. Okay, so then you have to crack it, and then you have to, okay, just wait. Okay, what is fracturing? What is fracturing in oil and gas? Yeah, I mean, I think you just have to crack it, right? Break it. Fracturing in oil and gas, commonly known as a fracking or hydraulic fracturing, is a well stimulation technique used to extract trapped petroleum and natural gas from a deep underground rock formation such as a shale or a tight sandstone. Drilling: a well is drilled vertically thousands of feet into the earth and turned horizontally to run parallel with the targeted rock layers, steel pipelines, and sediment like in the well bones to permanently seal and protect one corresponding performer is to tiny hole blasted into the smaller in a horizontal section of the pipe to create an exit point of the rock. A high pressure mixture of water, sand, and chemical additives called the fracking liquid is pumped into the wall. Fissures and proppants. The immense pressure cracks the dense rock, releasing the oil or gas. The sand flows into these fissures to keep them propped up. Open, the pressure is released. Okay. Why is it used? Historically, drilling relied on highly porous rock where the oil and gas flowed naturally. Fracturing is used for unconventional reservoirs like the shale beds, okay, where the rock is so dense, low permeability that the hydrocarbons cannot move on their own. By breaking the rock, fracturing transforms previously inaccessible non-commercial deposits into the highly productive resources. Okay. Environmental health concerns. While fracturing has revolutionized global energy supplies and lowered natural gas costs, it remains highly controversial due to several key concerns. Water contaminations. Risk that fracking fluids or naturally occurring radioactive material could migrate and contaminate underground drinking water supplies if cause casing fails. Seismicity. Right, to talk about the earthquakes, yeah, the practice of seismicity, okay, seismicity, the practice of injecting used water deep underground has been linked to induced earthquake. Methane leaks during the extraction process stage contribute to air pollution and damage. Okay, so you could talk about a lot of these things, but it is important resources. So yeah, so this is the example of a shale oil. Understood, right? Okay, and then yeah, so you have oil sands, deep water oil. So this became important as the easily accessible oil decline discussed. Okay, so why oil is called the liquid sunlight? Some scientists formally described oil as a liquid sunlight. Reason: ancient organisms captured solar energy through photosynthesis. That energy became stored underground. Humans today releases that stored energy through combustion. Essentially, cars today may be burning sunlight captured hundreds of millions of years ago. Yeah. Now this is the transition ending is to, for millions of years, oil remained hidden beneath Earth's surface. It was created by geology, pressure, heat, and time. But eventually, humans discovered this mysterious black liquid, and history changed forever. Now humans discovered oil, but how did it become civilization's bloodline? Shout out to Bistro. Now we'll talk about the part two. Excellent progress. Okay, discovery industrializations. Okay, now we'll talk about the part two. How oil built the modern world. Right? Can I don't think we can think of uh, anything to do with respect to any technology and all those things without thinking about oil. Right? For example, if you're talking about the roads, if you're talking about the factories, if you're talking about anything, old time, even the rain, even the railways, right? Everything runs through the oil, and it's important. It's very important. Even right now, most of the electricity, electricity is generated through oil, right? Thermal energy. And just wait. Part two is just how oil bill goes to introduction from a strange black liquid to global power. For millions of years, crude oil remained hidden beneath Earth's surface. Ancient civilization used a small amount of naturally occurring bitumens, oil, but oil had little importance in everyday's life. That changed in 19th century. human learned not only to extract oil but all transformed into a products capable of changing into civilization itself. Oil eventually powered industries, transportation system, wars, and economic developments. The modern world was built on petroleum. Edwin. Now we'll talk about the interesting thing as to how it was invented, right? Edwin Drake and the birth of the modern oil industries. The beginning of the commercial oil age is often traced to 1859. So we're talking about back in 100 and 60 167 years back. 167 years back. The beginning of the commercial oil age is often traced to 1859 when the former railroad workers named Edwin Drake drilled a well in Titusville, Pennsylvania. It's in United States. Okay, so Edwin Drake. Okay, and before Drake, this is all mostly sipped naturally from the grounds. Collections methods were primitive. Supply was extremely limited. Drake introduced a revolutionary idea. So he was the person who came up with this one. Instead of collecting oil from a surface seepage, why not drill into the earth? His well reached approximately 21 meters inside deep. The amount of oil production produced initially seemed small, around 25 barrels per day. Yes, its impact was enormous. This event became the foundation of the modern petroleum industry. Many historians call Drake the father of the modern oil industry. Let's fact check it. Uh, who invented the oil refining process? No. The world's first modern commercially successful oil was drilled by Edwin Drake, often referred to as Colonel Drake in this one. Okay, his innovative use of the dry pipeline to prevent. Okay, I want to know. Okay, uh, what is the machine called that extracts oil? It's rig, right? If I'm not wrong. Yeah, oil presser oil. No, okay, machine that extracts oil from plants, seeds, and nuts is plants. What is the machine that called extracts oil from the from soil or underground soil, any of the thing? Okay, yeah, it's called rig, oil drilling rig, right? The oil machine used to extract natural petroleum or crude oil directly from the earth is an oil. Okay, drilling rig. That's oil drilling rig. So this is the example of it. Extraction rig. So this is known as a rig. Oil pumps. And yeah, so Edwin, right? So he's known as Edwin. The father one is the first major product. So it goes to kerosene. In the 19th century, the world faces a major lighting problem. Lighting problems. People used candles, whale oils, animal fat lamps. So this method you had disadvantages: expensive, smoky, inefficient. Oil changed everything. Refiners discovered that crude oil could be processed into kerosene, and kerosene quickly became a revolutionary fuel for lamp. Advantages: brighter, lightning, cheaper cost, and cleaner burning. Cities and households rapidly adopted it. Ironically, gasolines, which later transformed transportation, was initially considered almost useless and often discarded. At the time, industrial kerosene was the true economic price. So let's look at how does kerosene look like. Okay, kerosene. So this is how it looks, kerosene. And yeah, is kerosene? It's not same, right? Is kerosene same as petrol? I don't think it is, right? Okay, no, kerosene and petrol, gasolines are not the same thing. Although both are hydrocarbons derived from the crude oil distillations, they differ slightly in chemical combustions, volatility, and usage. Petrol is highly volatile and used for internal combustion engines, while heating, lighting, and aviation fuel. Oh, is aviation turbine? That's what you turbine fuel. Kerosene. Kerosene. Yes, aviation turbine fuel is kerosene based. It is highly refined and processed from in a form of a kerosene designed to meet extremely strict safety performance and low temperature requirement for jet engines. While standard kerosene and this one share the same basic hydrocarbon function. Okay, so and because yeah, in aviation means jet fuel, they have a different fuel, right? So okay, oil and the industrial revolutions. As the industry expanded, nation required larger and more reliable energy supplies. So coal had powered the early century industrial ages, but oil offered us several advantages: high energy density. Oil contains enormous energy relative to its volume. Easy transportation, liquid fuels can be moved through pipelines, tanks, ships to more efficient storage. Oil required less handling than coal. Factories increasingly relied on petroleum products. Industrial production accelerated economic growth rapidly. This is the automobile revolutions. The 20th century transformed oil forever. The invention and the mass productions of the automobile created a new form of demand. Early automobile existed before mass adoption, but a major breakthrough occurred with the Henry Ford. Okay, so come up with the Henry Ford. He was the founder of the Ford Motors. Ford introduces assembly line manufacturing, making cars affordable to ordinary people. As vehicle ownership expanded, gasoline demands exploded, and road network expanded. Suburban developments increases. Petroleum became deeply integrated in daily life. Cars change because to where people live, how cities develop, labor mobility. Global economist. Oil was no longer merely a fight lightning fuel. It has become a transportation fuel. Uh, yeah, let's talk about this one. Okay, who was the first person to use car, you know, use car with fuel, right? With the petrol. So German engineer, Carl Benz is credited with building the first practical gasoline-powered automobile, the Benz. Okay, so German engineer Carl Benz, Mercedes-Benz, the founder of the Mercedes-Benz, is credited with the building this one and took her husband experimental motor car on this one. So okay, journey from the okay, it's her, is it? Okay, and on the go mechanic. During the journey, she also became the first mechanic and road trip. Carl Benz. Okay, just let's look up. Carl Benz. Was he the founder of the Mercedes Benz? Mercedes Benz founder. Carl Benz and okay, so it's Mercedes Benz was officially formed in 1926 through the mergers of the two companies founded by the automobile pioneers Carl Benz and okay. So he was the first person. Aviation connecting the world is equals to the emergence of aviation created another massive source of demands. Aircraft requires fuels with the emergence of the aviation created another massive source of demand equals to aircraft requires fuels with the high energy density. Emergence of the aviation created another massive source of demand. Aircraft requires fuels with high energy density, reliability, and stable performance. And jet fuel derived from petroleum became essential. Air travel transformed equals to tourism, trade, migrations, okay, and international businesses. Modern globalizations would be difficult without aviation. Today, thousands of aircraft operate daily. This one. Just wait, okay. Can plane run on diesel? No, standard road diesel is rarely used in commercial airplane. They primarily use kerosene based or this one. While some smaller propeller use plane uses a specialized piston diesel engine with standard this one's really elevated because it can freeze and get at high altitude blocking fuel filters. So they can be used, but the catch is that it might this one okay. Could airplane technically run? What type if not equals to this one okay. I'm a 5 is equals to okay, so depends on size. Okay, it's written uh, light aircraft most would run on the petrol, but it will do it some damage unless approved for more gas, motor gas rather than air gas. You get some diesel engine light aircraft that run on jet engine, but that will run on diesels as the two are in million parts. Large aircraft, a turbine will basically run on anything combustion and combustible within reason. Some turbine engines are approved to run on avgas. Okay, avgas means aviation gas for very limited times under a certain condition, but it would require maintenance after petrol is goes to again would run, but it isn't going to do any favors and likely damage. Okay, so it can be run, but it likely do a damage. Newer computer control engine is to okay. Okay, now we'll talk about the oil and military powers. Oil also, reshaped warfare during earlier centuries. Armies depended on horses, coal-powered, ship. 20th century warfare introduces tanks, aircraft, submarines, mechanized to transport oil. Okay, oh yeah, armies move on fuel. Oil, shortages could influence entire campaigns. Control cover over oil resources became a geopolitical objective. So, okay, we'll talk about this in details later. Right? I will talk about how global oil demand changed through time because the oil demand did not grow for one reason. Different periods have different drivers. Around 1900s, the lightning era, primarily used for kerosene lamp, demands remained relatively small. Oil was mainly associated with the lighting and limited industrial uses. Around 1950s, the automobile age. After the Second World War, car ownership increased dramatically. Highway expanded, and gasoline demand surged. Petroleum became central to the transportation. Around 1980, rapid industrializations. Okay, developing nations expanded manufacturing infrastructures. Okay, so around that time it happened. Heavy industries, the oil demand broadened by beyond transportation, economic growth accelerated energy consumption. Around 2000s, the rise of the China. Rapid growth in China transformed global energy market. Industrial expansion created huge demand for factories, shipping, construction, and transportation. So China became one of the world's largest energy consumer. I'm sorry. Global oil trade pattern changed significantly. 2020 and beyond goes to Asia's growth, demand goes to today much energy, future energy demand come from India. India has a huge demand. Just wait, okay, let's see. How much oil does India consumes per day in a single day? So, okay, consumes, right? Okay, oil production. So, India produces 952,481 barrels per day. This is the productions, and in terms of ranking, it's 20th in the world ranking. Consumption, they consume 5.5 million barrels per day. That's a lot, and there's a deficit of this one, and the deficit is met by import. What does import mean? You have to buy from outside, and if you're buying from outside, then obviously you have to pay the foreign currency, and foreign currency, obviously, there's nothing, there's no other than the dollars, and then you have to pay more dollars. When what happens when you pay more dollars? That means basically you have to buy more dollars. What happens when you buy more dollars? When you buy dollars, that means obviously you're selling something. You have to pay something. What do you pay? You pay rupee, and the demand for dollar increases. The supply for the rupee increases. When the demand increases for the dollar, obviously the supply of the uh, rupee also increases, because basically you're paying in a rupee. So supply, demand, currency, there's a inflation, there's a currency depreciation of rupee, because less demand, more supply. That's how it is, right? So that's why oil plays a very important role. See, just to give an example, right? Anything. So I'll just give you a basic explanation of what is inflation. Inflation basically means increase in the general price level of a commodity in a country, right? And if you're talking about this juice, if you're talking about this cell phone, right? What happened is that if I want to buy this, right, it has to come from somewhere, because it is not produced here. Right now I'm in a Bangalore. Not necessarily it has to be produced in Bangalore, right? It comes from around the country, entire country, China, Vietnam, and all those things, right? How does it come here? You have to pay for the transportation, right? The company pays for the transportation. How does it come? Most of the trading, I think more than, okay, just wait, uh, percentage of trade that happens through sea. Yeah, so here, look at it. 80% of the world trade happens through ocean, right? Or even the this one, the flight, it's more expensive, right? So that's why most of the it happens in through ship, right? Because it's it's less to cost for the these things, but it'll take a lot of time, 30-40 days on an average, right? You have to pay for the, and then how does it come? It runs on the the oil, and oil price increase, that means the transportation cost increases. Transportation cost increases means the company has to pay more, and they will not pay. Obviously they had to ship that burden, so we have to pay ultimately. So that's why oil prices are very important. It actually leads to inflation. uh, so now we're talking about this one. Okay, Asia's, okay, reason includes population growth, urbanization, rising income, industrial developments. So Asia increasingly shapes the global oil market. And for India specifically, growing vehicle ownerships and industrial expansion continues to increasing energy requirement. Okay, now we'll talk about the suggested visuals. The world consumptions, okay, trend charts equals to create and timeline graph. Okay, so this is the it's like a graph, but I cannot do it, so that's why I just kept it like this. Okay, this is 19 in this one. So okay, 1990s lighting, automobile industrial growth, China expansion, Asia demand growth. The curve should begin slowly and then rise sharply. The visual demonstrates. Okay, now it's interesting fact is goes to the United States was both, okay, United States was both once both the world largest oil producer and the world's largest oil consumer also. And so see, okay, if you're in a country, if your country is producing a lot of oils and you're able to fulfill that demand by buying it yourself, then it's not a problem at all, right? Because you can fix the price of the oil. But the problem comes for countries like India, where you basically don't produce a lot and you have to buy from a foreign country. Now the problem comes in a war-like situations where the transportations, where the because most of the time what happens is that I will talk about this in more detail. That if there's any choke point, if there's a place, if it's coming from, and that place is blocked because of the war and because of the political situation in the specific country, then what happens? Your oil prices increases. You don't do anything because of the global reactions and all global because of the doing of the global countries, other countries. You have to suffer, you have to pay more prices, right? That comes the problem. It's because India does not produce a lot of oil. So that's why right now the prime minister is in UAE, They're talking about because of the recent war, they are talking about the different routes for the transportations of the oil. And right now there's a shortage of oil in the entire world. Shortage does not mean there is no oil. There is oil, but the problem is that it cannot be transported because the transportation road is blocked because of the Strait of Hormuz. Okay, now more important points often missed. Okay, early oil discoveries in Pennsylvania and later, giant field in places such as the Texas helped establish American industrial dominance. And for decades, United States, shaped the global oil market. Important point often missed is goes to oil built more than fuel. Right? Okay. Important points often missed goes to oil build more than fuel. People often think oil simply powers engines. Power, however, petroleum can also be essential for plastics. Yeah, fertilizers, synthetic fibers, pharmaceuticals, chemical packaging deal. So most of the people think that the crude oil is only for the oil and to for the petrol and diesel and aviation turbine fuel. No, it actually helps in manufacturing or making of the pharmaceuticals, chemicals, packaging materials, even the plastics. Right now, all the plastic it comes from that oil only. Fertilizers. Okay, we'll talk about it later. Modern life extends far beyond gasoline. So a large portion of everyday products depend either directly or indirectly on petroleum. Transitioning industry with only a century, oil transformed them from an obscure underground substance into the foundation of the industrial civilization. Demand expanded and response of transportation. Okay, all those things. Okay, part 3 is goes to now we'll talk about the from crude oil to everyday products introductions. Now we'll talk about it. Introductions. Crude oil is not used directly when crude oil comes out of a ground. Okay, so now we'll talk about the step-by-step process of what exactly happens when that oil is extracted. When it is extracted, it is a crude oil. It has to be refined, and then it can be converted into some other useful products. So when crude oil comes out of the ground, it simply cannot poured into a cars or airplanes. Freshly extracted crude oil is a complex mixture containing hydrocarbon of a different size, sulfur components, impurities, gases, water traces, heavy materials. So it contains all of those things, and it appearance varies equals to. Okay, so I told you the Venezuela is a proper black, and little greasy. So appearance varies. Black, it could be dark brown, it could be greenish. Sometimes it's also sometimes almost golden. Some crude oils are light and flow easily. Others are thick and heavy. To become useful, crude oil must undergo a major industrial process, refining. Refineries are essentially a giant industrial system designed to separate and transform crude oil into a useful products. Right now, okay, what is an oil refinery? An oil refinery is a massive industrial facility where crude oil is heated, separated, purified, and chemically modified. The purpose convert one raw material into a. Okay, so I think that could be a right word to use, right? Crude oil is a raw material, and that could be used for different reasons depending on how many what are the pressures, what are the the chemical that it has been mixed. So heated, separated, purified, chemically modified. The purpose convert one raw material into dozens of useful products. Modern refineries are among the most complex industrial structure ever built. They operate continuously 24 hours a day, 7 days a week. Many process hundreds of thousands of barrels daily. Right. Step one, crude oil enters the refinery. Okay, so this is the step-by-step process. Okay, step one, crude oil enters the refinery. After okay, just to give a little context of refinery. How does refinery look like? This is how the refinery looks like. This is how the refinery looks like, right? And after transportation through after transportation through pipelines, ships, rail system, tankers, trucks, crude oil reaches the refinery. The first major step, heating. Large furnaces raises temperature to approximately 350 to 400 degrees Celsius, and the heated crude becomes a mixture of liquid and a vapor. The crude becomes a mixture of liquid and vapor. This hot mixture enters the refinery most important structure, the distillation tower. Distillation, okay, distill basically means purifying. The distillation tower separating oil like a giant chemical elevator. The distillation tower is a tall vertical column. Its job separate crude oil components based on their boiling points. Yeah, so interesting is that now the question is, how do you convert all of those raw crude oil into different products, right? Everything depends on the boiling point. If you boil at 100 degrees Celsius, this one will come. If you boil it again like 120, this will come. So this is how it is. See, okay. Separate boiling point equals to, okay, the distillation tower is tall vertical column, separate crude oil components based on their boiling points. Different hydrocarbons boil at different temperatures. Lighter molecules rise higher. Okay, lighter molecules rise higher, heavier molecules remain slow. Think of it as a giant sorting machines. Hot vapors rise upward as temperature gradually cools at a different level. Substances condense into separate fractions. Visual ideas. Okay, imagine a tall tower, hot at the bottoms, cool at the tops. Production leaves at a different lights. Okay, and top of a tower, right? Okay, top of a tower. So I'll just show you something. And refinery. Okay, uh, how crude oil, used as raw material for different things. So yeah, it could show you. Yeah. So this is the thing. No, something better. So yeah, this is the actually a good this one, right? A good visuals to show to you, right? You could see here, right? This is the entire thing. So this is just example. This is the distillation tower. Okay, this is the entire crude this ones, and this is the refinery, and this specific part is the distill tower. This is the crude oil, and it goes through this entire thing, and it's heated furnaces. Okay, heated and all those things, and then when it goes there, so based on the heat, right? Okay, see, at 25 degrees Celsius, it becomes this thing. Okay, petroleum gas, and if it's between 25 to 60 degrees Celsius, it becomes a gasoline, petrol, and 60 to 180 degrees Celsius goes to it becomes naphtha, and at 180 to 220 degrees goes to it becomes paraffin. I think it could be a jet engines, jet fuel, and 220 to 250 goes to it becomes a diesel, and 250 to 300 it becomes a fuel oil, and at 300 to 350 is it becomes a lubricating oil, and at more than 150 it becomes the bitumen that is used for the road construction and all those things, right? So yeah, this is the classic thing. Okay, this is that. And I think, is there any a more way to show about? Okay, okay, so this is actually a good a good thing, right? So one barrel of crude oil, if extracted, one barrel, it contains 159 liters to 42 gallons. And for in this one it contains, if refined, once refined, a barrel typically produces about 73 liters. 73, okay, 73 divided by 159 into 100, around 45 percentage is petrol. And the most is the petrol, right? Okay, and then distill equals to 37, and then jet fuel is equals to 5 percentage, asphalt 3 percentage, others is equals to 6, others is equals to include the plastic and all those things. So now the question is, okay, top of a tower, okay, all of those things is done. Top of the tower, light products, okay, at the highest level, coolest and section. Okay, so now we'll talk about this thing. Top of a tower, just imagine a tower, that thing, a light product is equals to, at the highest and the coolest section, the very light molecules emerges main product, LPG. We use it for cooking, right? Uses goes to cooking fuel, okay, household gas cylinder, industrial fuel, heating. In countries such as India, LPG cylinders are commonly used in homes. Okay, other gases separated includes goes to propane, butane. Middle of the tower, transportation fuel goes to top. The middle section produces product daily. Gasoline, petrol goes to use for cars, motorcycles, small engines, and kerosene goes to use for aircraft, fuel productions. Heating is to lighting in some regions. Jet fuel is closely related to kerosene. Diesel is to one major fraction often collected around the middle lower regions. Diesel powers trucks, buses, agriculture equipment, generators. And okay, yeah, truck mainly runs on this one. And diesel remains extremely important in economies like India due to transportation and logistics. The bottom of the tower, heavy product is to large hydrocarbon molecules remain at the bottom. This includes the heavy fuel oil used for ship, industrial facility, lubricants, reduces frictions in machinery, wax used in the candles, in packaging, cosmetics. Okay, just wait. Okay, how does cosmetics? How, okay, crude oil is used, used in cosmetics. I don't know, man. Okay, isn't just for fuel. It also used to make everyday items like the detergent. Okay, detergent, fertilizer, plastic, even cosmetics. I don't know how. Okay, cosmetic feels just okay. All those things. But is it healthy? Yeah, I don't know. Yeah, yeah, plastic. Yeah, fuel. Yeah, paint. Yeah, even the paint. Yeah, medicine also. Synthetic fiber, asphalt, tar, lubricants, chemical. Hmm. Interesting is goes to. Okay, cosmetics, bitumen asphalt goes to use for road construction, waterproofing. Interestingly, the same bitumen used by the ancient civilization still has important uses. Right? Refining does not end at distillations. So, okay, it's not the end, right? Refining does not end at distillations. A common misconception: distillation alone creates all the petroleum products. Not true. Refiners perform many additional processes. Cracking breaks large molecules into smaller valuable product. Example: heavy oil equals to gasoline. Reforming changes molecular structure into improve fuel quality. Desulfurization removes sulfur to reduce pollution. Okay. Blending combines product to meet quality standards. The process maximize economic value. And okay, now this is done. Just wait. Okay. Uh, does does production of petrol and PET or petrol and diesel cost the same? No, the production and the refining cost for petrol and diesels are not exactly the same, though they are very close. Diesel generally costs slightly more to refine because it requires additional processing to remove sulfur and meet a strict environmental emission standard. Refining and production cost. Base crude. Both fuel come from the same barrel of crude oil and share initial distillation cost. The difference is diesel require extra hydro treating to remove the sulfur to produce ultra low sulfur diesel, making its production cost marginally higher than petrol. Supply, and demand equals to market pressures. Production cost only make up a portion of the real. Okay. Okay. So yeah, it's not the same. Otherwise, it should be same, right? Because it's deriving from the same thing. So a little okay. The big surprise: oil is everywhere. Many people assume oil simply becomes fuel. Reality is far more surprising. Petroleum acts as a raw material for thousands of products. Oil enters daily life in a way most people never notice. Example includes plastic bottles, water bottles, and packaging, often originating from the petrochemicals. Phone cases, many synthetic material comes from petroleum-based plastic, toothpaste. Certain ingredients and additives may derive from the petroleum products. Many pharmaceutical chemicals depend on petroleum feedstock. Fertilizers. Modern agriculture heavily depend on the petroleum and natural gas products. Without them, the global food and production would look very different. Clothes. Synthetic fibers includes polyester, nylons, arca-like. Many clothes are perfectly, partly petroleum products. Detergent goes to numerous cleaning compounds origin from the petrochemical industry. Cosmetics such as the lipstick, cream, production such as the lipsticks, creams, and lotions may contain petroleum-derived ingredients. Tires goes to vehicle tires use synthetic rubber and pharmaceutical, petroleum characteristic materials. Now, important point often missed is goes to agriculture runs on oil too. People often think food and oil are unrelated, yet modern farming depends on petroleum through fertilizers, pesticides, machinery, fuel, transportation, packaging. Oil, indirectly supports food systems worldwide. Visual suggestions create a diagrams to send us goes to 1 barrel of crude is goes to okay. So yeah, this is okay. I was talking about, right? So fuel, plastic, medicine, clothing, cosmetic, agriculture. This shows one, so goes to engagement channel for an audience. Pause for a moment, look around to your phone, clothes, toothbrush, shampoo. How many petrol product have you touched daily? Okay, transition goes to. Then we'll talk about the best. Uh, Part 4 is equals to the journey of oil, ships, pipelines, and giant tankers. So now this is actually the origin of oil. Now we'll talk about the geopolitical ramifications, and yeah, we'll talk more about all of those things because see, okay, the prices of the oil is very important. So it is not only derived from the transportation cost. Yes, transportation cost also it plays a very important role, but detergents, detergents, right? Deterrence it also plays a very important role. For example, uh, right now, uh, the entire Strait of Hormuz is blocked, and that means the okay. So normally, what happens is that most of the petrol comes from comes by ship, right? And you have to pay for the transportations. And since the Iran has blocked the road, it has said that anyone who tries to cross this one, you know uh, we have how do I say it? We have kept a mine over the narrow ocean in that Strait of Hormuz because Strait of Hormuz is a very narrow one because it's just a I think few kilometers wide, and anyone who crosses it, they might get attacked from that mine and all those things to trigger. So then what happened is that most of the the ship the cost is very high, so that's why if the cost is high, they get insurance. So now what happens? Insurance cost will skyrocket because uh, there's a threat, and the chances, the probability has has risen significantly the damage. So you have to pay more for the insurance. When you pay more for the insurance, then obviously you have to pay more for the entire oil, and then it goes on cascading effect, and then at the end you have to pay more for the everyday products. So now we'll talk about all of those things, and part 4 is the journey of the oil, ships, pipelines, and giant tankers. Hook: oil extracted in Saudi Arabia can take over a month to reach Asia or America. That is exactly what I'm saying. So right now, even if the situation is solved, it might not, we might not see the effect, today. We will see the effect after 40-50 days, because just imagine, okay, when one ship crosses today from the Strait of Hormuz, it takes, just a rough estimates, 30 days, right? To come here, crude oil, it has to be refined and then it has to be distributed. The refine doesn't happen every, all the places. It happens in the Gujarat, the Jamnagar. After refining, it will take some time and it has to be transported to every, other, major cities, right? And yeah, not just in this one, Gujarat, some other places also happens, but more or less like, not in a, not, doesn't happen everywhere. So it has to be transported at the end of, to all the, petrol pumps. So if it crosses, just wait, okay, right now today it's 17th May. So if it crosses today, then it'll come next month, 30, 17th June. It'll come in India 17th June. All in all, it'll take like 30 days and then one more week. So if the ship crosses today, we will see the effect after 30 to 40 days, right? And so because of that, the prices will not change till this one comes, right? So see, okay, right now it's been like almost 76 something days of the the blockage at the Strait of Hormuz. Now we are able to see the effect, because the last ship, I mean technically, the ship, right, the Strait of Hormuz, it has been closed since 60, like close to 60 to 70 days, but the ship, right, which has crossed 30 days back, I mean more than 60 days back, some ships are still coming. I'm just talking about rough estimates, okay? I'm not talking about now. There's no ship at all, right? I was talking about, right now it's 75th day, but before 30 days, the ship was still coming, because it was going daily, right? It was daily and going daily from there, but it reaches after 30 days. So some countries could only, see the effect after 30 days, because the ship had, was still coming from there, because the ship has crossed 30 days earlier. So right now some ship is coming now, but now, because the time frame has all gone, now we could see the, some, the effects of the price. And yesterday itself, gradually, if you see all the country, right, most of the countries who are oil dependent from other countries, they have, right, have risen, okay, they have increased their oil prices from way back 20-30 days. Now we could see in India, yesterday itself, 3 rupees has increased, and most of the experts believe that this is the first installment, and first in the installment, that means it will increase, but you don't increase, dramatically. It has to be increased, it will increase, gradually, because you don't uh, you don't actually alert, shock, or just give unprecedented, or I mean, you don't do that directly, right? You don't directly, attack the common people. You just do it, gradually, so that the people also can absorb the shock. I'm not saying this is the government's fault, absolutely not, but you have to see the reserves. They could have, maintained a bigger reserves. Otherwise, this is not any one country problem in a sense. It is not India's fault as such, because this is beyond the control of any one to, a country, or who have done literally nothing in this entire war. This is external matter which is now impacted. Could India have done better? Obviously, yes. And could India have done worse? Absolutely, yes. But more or less, we could have like a more reserves, like 150 to 200, or even more reserves, which will, give us a cushion to, slowly increase the price, or not even increase the price, right? But we don't have that much of reserves, so because of that, now we have to gradually increase the price. And right now the strait is still closed, apparently. So the part 4, the journey of oil, ships, pipelines, and giant tankers. Hook: oil is extracted in Saudi Arabia, can take over a month to reach Asia or America. Why? When oil is discovered in the ground, extracting it is only half the challenge. The next challenge is enormous: to moving billions of barrels of, safety across deserts, mountains, ocean, political borders, and countries. Modern civilization depends on one of the largest transportation network ever built. every day. Oil travels through pipelines, tankers, trucks, rail system, ports, giant crude carriers, ocean shipping routes. With this transportation system, oil fields would have little value. Now hidden arteries of the world. The pipeline are often called the arteries of the global energy systems. Just as blood vessels moves blood through the body, pipeline oil moves continuously over a long distance. This system uses plumbing, pumping stations lift at intervals to maintain pressures and keep flowing. Some pipeline stretches thousands of kilometers across countries and continents. Many remain buried underground. Others crosses mountains, forests, desert, and foreign regions. Advantages of pipeline: lower transportation cost. Okay, so the good thing about if you have a pipeline, it's basically like a pipe, right? You don't need any of those things. Just have to own it from that country, and then it'll come there, right? The problem is that the initial fixed cost is very high, and also you have to maintain it. But the cost, right? The cost of delivery is very low. And what if someone comes and, because we're talking about the two big countries, right? Two very far, thousands and thousands of kilometers away, right? That means in the middle there might be some international waters, there might be some other country in between any of numbers of this thing, right? What if someone accidentally, or if you have a war with one country, then obviously the enemy will do anything to ensure that your oil supply remains disrupted. So what if they damages in this one? So that's why it's very risky. So, okay, one lower construction cost over land. Once constructed, pipeline can transport large quantities at relatively low operating cost. Moving oil through pipeline is often cheaper than using trucks or trains. Continuous supply. Unlike trucks or ships, pipelines operate continuously. Oil can flow 24 hours a day, 7 days a week. This creates stable energy crisis, reduce traffic congestions. A single pipeline can reduce thousands of truck journey. Disadvantage of pipeline is that despite their efficiencies, pipelines have a major limitations, fixed routes. The pipeline cannot easily change its destination. Once built, the path becomes a permanent. Changing routes often requires a major reconstructions. Extremely expensive construction. Building pipeline requires engineering studies, land acquisitions, okay, environmental assessments, pumping stations, maintenance systems. Construction cost can reach billions of dollars. Political risk. A pipeline often crosses multiple countries, or when a political disruption disputes can interrupt energy flows. International tension sometimes creates uncertainty. Energy infrastructure therefore becomes geopolitical issues. Famous pipeline explains this. So yeah, so we'll talk about the famous this one. Trans-Alaska pipeline system, length approximately 1,300 kilometers. Purpose: moves crude oil from northern Alaska to southern ports. It crosses mountain forests, extreme cold regions. The engineers had to solve problems involving frozen ground and earthquakes. Obviously, right, because Alaska is a very cold country. It snows most of the time, right? So when you, and even in right now, even in Missouri, in the place where I used to stay, right, the pipeline, sometimes it just during winter, it's when it's very cold, the entire pipe is blocked, because of the weather temperature, right? The entire water is blocked. What do you do when you're transporting, right? So yeah, you have to take the into considerations. So Russia, Europe gas and this one, Russia, Europe gas and oil pipelines networks. Energy pipelines connecting Russia and Europe has historically played major economic and geopolitical roles. So this network demonstrates how energy transportation can influence this one. So, okay, Russia, Europe, this is very famous. So right now, because Russia is war with the Russia and Europe, Russia versus Ukraine. So the Europe is supporting Ukraine. So there's a indirect war between Europe and Russia. So even now they've built this much of a construction cost and all those things for the pipeline. Now because they are not friends, they are enemies, so to say. Now, if they don't do any transportation later, or if they don't buy and sell, do the transaction later, then obviously their entire thing is of no use. And then what about the fact that you've spent so much for the in the first thing? Why not transport everything through pipelines? That's a natural question. Yes, you could have done this if considering ceteris paribus. That means everything remains equal, constant, right? But it isn't. There will be a conflict. There will be some misunderstanding between countries, and yeah. So just imagine, okay, Europe and the US was considered as the best friends, but now what has happened? Especially in and US and Canada also has considered as to be best friends, neighbors, same language, almost same culture, same tradition, everything similar. But now relation is not good, right? So what do you do in that kind of situations? So yeah. And despite their efficiency, major problem is the pipeline cannot easily test and okay, this one's built. Disadvantages, okay, where was I? Yeah. Natural question is, if pipelines are efficient, why not build pipelines everywhere? The answer involves geography, economics, and politics. Ocean, separate continents, pipeline across entire countries are extremely difficult and expensive. Yes, just imagine if you were to be, okay, I'll just give an example, right? Okay, India map in the world. So this is the India map. This is the India map in the world. I'll just show you. This is the India's map in the world, and